We're going to concentrate on the term variable for this lesson. A variable is defined as any specific characteristic of the individuals in a population. This could be the weight of the individuals in the population. This could be eye color, various other types of characteristics that you could describe that could be a variable. There are two types of variables. We often call them the two Q's. The first type is called qualitative. So qualitative variables are usually non-numeric, but there are some exceptions to that. The idea is they're the type of variable that you use for classifying individuals based on some attribute. You also have quantitative variables. Quantitative variables are numerically based, and they're all about providing numerical measures of the individual. So just as a quick rundown, so qualitative, you could have, as I mentioned earlier, eye color. So eye color is a way to classify the individual based on some attribute. Whereas quantitative, it could be weight, and weight is a numerical measure for that individual. Students often ask me after this, well, you mentioned that a qualitative variable could be numeric, and that often doesn't make sense to them, which is perfectly fine. I get that. But one thing that you can think about is quantitative variables should be able to be subtracted or added to create some meaningful results. So in terms of weight, right? So if you have a dog that weighs 80 pounds and a dog that weighs 50 pounds, then you subtract them, that 30 pounds means that dog weighs 30 pounds more than the other one. It's meaningful. But what if you took something like area code, for example? So area code, most of the area codes in this area are 908. There are some that are 201. Subtracting area codes has zero meaningful result to it. There's nothing there. So believe it or not, area code would be considered a qualitative variable because we are using it as a way to classify individuals. We're not using it as a numerical measure for them. We can actually break down quantitative variables into two other types of variables. One is called discrete, and one is called continuous. Deciphering between these quantitative variables is very important and something you will have to do on exams. Discrete, for example, is all about the concept of a count. So what does that mean? That means the number of pets that you own, the number of cars that you own. It could mean any number of counts, so counting numbers. In other words, not decimals. Continuous quantitative variables are usually measures of some kind. So, for example, weight is a measure. Length is a measure. These are things that could have decimal values involved with them. So you could weigh 100.7 pounds or something like that. The key is that I always talk when I talk to students about this and give them sort of pointers on always remembering this. Basically, any quantitative variable that could be a decimal, even if it's not looking at it, is a continuous variable. What can be confusing about this, by the way, I often use the example of a scale, a weight scale, let's say, that you have at home where, you step on it, it tells you how much you weigh. When you look at that, usually it says just the weight. It could be rounded to the integer value. So, for example, it'll say 123 pounds, let's say. But the reality is you don't usually weigh exactly 123 pounds when you step on it. Instead, you probably weigh 123.0736 or 123.235 or something like that. Could even be 122.87. It's because what's the scale doing? The scale is programmed to round your decimal value. So even though you might look at the scale and see an integer value, a countable number, It's not about that. It's about whether that number could be a decimal. If you're counting how many pets you have, that number cannot be a decimal, which means it's discrete, whereas your weight be continuous. All right, let's do a quick example just to make sure this is good. So what you're going to see right here is a table that is about earthquakes, okay? So you can see the word magnitude here, which is a good clue that we're talking about earthquakes. So what you're looking at are 4 variables. So each one of these guys are variables right here in yellow. Variables. Each one of these variables is considered either qualitative or quantitative. We have to distinguish that. Now, I think everybody's pretty clear with region, time, and magnitude. This right here, I had to look up the first time I saw it. It's actually number of stations. Number of stations, so that everybody knows what that is. So what we're going to do here is we're basically listing out all the variables, which I've already done down here. We need to designate those as one of our key cues, qualitative or quantitative. And if it is quantitative, we need to go even deeper and describe it as discrete or continuous. So what does that look like here? Well, our number of stations. Clearly, this is a number value that we're dealing with that will measure some quantity. So we're dealing with a quantitative measure. But is it a count or a measure? Well, can we have a decimal number of stations? Clearly we cannot. There's no such thing as half a station. So therefore, this is clearly a countable value, which means we're dealing with a discrete quantitative value. Okay, next we have region. Region clearly is non-numeric, so this has got to be a qualitative variable. There's no further classification beyond that, as you saw here. There's nothing here, so we're good to go. Time, this is the time in which this earthquake took place. And remember, with time, this is something that you can subtract, because you can say, well, 5 o'clock is 2 hours later than 3 o'clock, which means it's clearly going to be a quantitative variable. The question is this something that is countable or measurable? So just by the nature of time can go deeper and deeper and deeper. So when you look at a clock and you see, let's say it's 11:35 a.m., right? So you look at that and you go, well, technically there's more beyond that. There's seconds, there's milliseconds, it just keeps on going. All of those are technically decimal values. So therefore, this has to be a continuous quantitative variable because it is a measure. Finally, our last variable is the magnitude of the earthquake. Magnitude is clearly a numeric value, which we can use as something to measure the earthquake. So this is definitely going to be quantitative. And if it's a measure, it's going to be continuous, but it makes sense. You can see decimal values there. Clearly, if we're dealing with, let's say, a 1.8 magnitude earthquake, then that was rounded from 1.81 or 1.79. It's not exactly what it is. The decimals can keep on going. So we're dealing with a continuous variable.